Hello friends, this is day 7/8, put together fun stuff about 7.3. This unit circle, learn it, live it, love it. You don't have to memorize by any means. It's just cool to kind of see every radian measure with its x and y coordinate. Keep in mind, let's get going here. Keep in mind, every point here, this is the x, this is the y. X is really cosine. Y is really sine of that angle. I'll just put of the angle. And in this case, the angle for this one is pi thirds. I could always make a nice triangle here and look at it that way. But this unit circle shouldn't be intimidating. It should be fun. Okay, so this is where it all builds from. Notice as we go around, all these x's are positive here, but then when you go this direction, the x's are negative because it's going to the left of the origin. Everything in this quadrant down here is both negative. X is negative and y is negative. So it kind of highlights all of those in one spot for you. Today, we're going to talk about the four-step process. Woot woot! We did this four-step process with degree. So you'll see even today, we will go back and forth from degree and radian just to kind of refresh on what you should know. But the four-step process is all about your reference angles. So here's a quick recap on your reference angle. So once you draw your angle, this one's 135. The reference angle is going to be made with the x-axis, it's going to be acute, and it's always going to be positive. Okay, so I'm going to write this down. Your reference angle has a couple properties. One, it's acute, so it needs to be less than 90. So that's telling me that here I'm going, this has to be the reference angle because it's acute. It can't be this measure to this x-axis because that's obtuse. So it's already telling you where it needs to be. It's even going to be acute, and I'll even write, it's the angle made with the terminal side and the x-axis, that horizontal axis. So if I'm looking at this picture again, this is acute, yes it is, but this is the y-axis. That's not my reference angle. It needs to be made with the x-axis. And the third fact is it's going to be a positive measure, which you can see in our last example here. Yes, the angle is negative pi fourths, but the reference angle made with the terminal side and the x-axis is positive. Here are other two examples. We interchanged degree and radian to show you how they are the same. So we're going to do the four-step process today with angles in degree and radian mode. Let's get going. Evaluate each without looking at the unit circle. Okay, so that's without using that front page that has all the answers for us. We're going to actually draw it out. Step one, as always, is draw your angle. So here we go. Now, 3 pi over 4. We have to figure out where that is. If I'm drawing, here's pi fourths, here's 2 pi over 4. This right here would be about 3 pi over 4. This is pi fourths, 2 pi over 4, 3 pi over 4. It's not going to be all the way down here because that would be 4 pi over 4, which is really just pi. So it's just a little bit left over. That's my angle. Now I have to find my reference angle. Well, the reference angle needs to be right here from the terminal side to the x-axis, and it's acute. So think about what's left over. If this is pi, or you can even think of 4 pi over 4, and my angle is 3 pi over 4. What's left over is a pi over 4. That's subtraction 4 pi over 4 minus 3 pi over 4 is just pi over 4. So that's your reference angle, pi over 4. We're now going to find my sine at pi over 4. Pi over 4, if you want to think about it, is 45 degrees. You may always, and I might just draw it up here so that we have it, have a nice triangle. Have your pi over 4, sorry, this is a little tight. And it's the same ratio as always, L root 2. You can also draw one for our 30, 60, 90, or our pi over 3, pi over 6. So this one's 30, so across from 30 is L root 3, 2L. It's just like degree. You can even change this into degree if you want. Looking at it, the sine of pi force is L over L root 2, but you will rationalize that denominator. We're in the second quadrant. So quadrant 2, think of your all students take calc. I'm in quadrant 2, that means sine is positive. So you just followed your first 4-step process. Sine of 3 pi over 4 is positive root 2 over 2. Let's try a couple more. Sine of pi 6. Draw your picture. Pi 6 we know is in the first quadrant here. So actually, maybe I'll just stick with what we're used to. I'll draw like that. Yeah. Okay, so that's pi 6. The reference angle has to be acute and with that angle. Like, wait, hold on. This is already done. This is a normal 60 degrees. I don't even have to worry about drawing the 4-step process. But if you're in the habit, keep going. Not wrong. The reference angle is the angle. I'm finding the sine of pi over 6. So using my triangle, sine of pi over 6 is L over 2L, or 1/2. We're in quadrant 1 where all is positive. So this one you did not even need the 4-step process. Trying our next one. 4 steps. Let's draw my picture. This time it is a negative measure. So I'm going to go clockwise. Negative 2 pi over 3. This is 0. This would be negative 3 pi over 3. So I know I'm a little bit over half, and then I'm stuck. So maybe like here. That's my angle I'm looking at. The reference angle is this positive acute angle that gets me from 2/3 to 3/3. So that positive pi thirds. So my reference angle is pi over 3. Cotangent of pi over 3. You can look at our picture above. Cotangent would be L over L root 3. Rationalize that denominator, root 3 over 3. We're in quadrant 3. All students take, so that means tangent and cotangent are positive. So the cotangent of my negative 2 pi over 3 is actually a positive root 3 over 3. Next one, cosecant of 7 pi over 4. Let's graph it. Here is 0, going positive direction. This would be 4 pi over 4. And if I go all the way, this would also be 8 pi over 4 because it's 2 pi. So I know I have to get pretty close to almost a full rotation, but have a little bit left over. Okay, so I'm here, 4 pi, there we go, leaving us with just 1 pi away, pi over 4. That's my reference angle. So reference angle is pi over 4. Cosecant of pi over 4 is the reciprocal of sine. So if I go to my picture, the reciprocal would just be root 2 over L, or just root 2. We're in quadrant 4. All students take calculus. We're with cosecant though, so that's really sine. Sine is negative. So the cosecant of 7 pi over 4 is really negative root 2. And now that is your 4-step process in radian. The next group is 4-step process with our degrees. So back to chapter 6. It's the same 4-step process, but now you're looking at degrees. I'm going to jump around and just do a few. If we want in class to go through more of them in detail, I would be happy to. But let's look at just sine of 135. So first one right here. I'm going to draw it. Get about right here, leaving me with a reference angle of 45 degrees. So reference angle 45, we're back to degrees. Sine of 45 degrees, you can look at your picture or you can know that it's root 2 over 2. Quadrant 2 means sine would be negative. So really, sine of 135 equals negative, sorry, it is not negative. All students means it's positive. Sine is positive, root 2 over 2. Now another way to think about it, sine is the y value. So of course the sign right here is positive. It's going up. That's another way to look at it if you don't really understand the all students take calc idea. It's the same thing. From the rest of them, you can find with the 4-step process or using what we did on day 5. X squared plus y squared equals 1 in solving that way. So many options are brought to you now. You can choose to do these ones. I'm going to quickly write the answers though if you want to check. So cosine of 135 should be negative root 2 over 2 because that x value is negative, which means the tangent would be negative 1. Cosine of negative 120 should be negative 1/2. If you do that, this would be positive root 3 over 3, and this should be negative 2. I'm going to quickly draw that angle for you. Negative 120, leaving you with the reference angle from here to the x-axis being 60 degrees. And that will help you then find your answers. Okay, this is a 4-step process using the angle negative 7 pi over 4. I will do this one with us. When you graph, here's 0, it's negative, so you're going clockwise. So it'd be 4 pi over 4. This would also be 8 pi over 4. So that means I get really, really close to a full rotation, but have left over a pi over 4. So, reference angle is pi over 4. I want to find the secant of pi over 4. Secant is 1 over cosine. So the cosine is normally 1 over root 2. So the secant is just root 2. We are in quadrant 1, so all is positive. So the secant of my negative angle in radian is positive root 2. Because secant is 1 over cosine, and cosine is the x. This is positive. It is going to be the same reference angle for cosecant, so this is going to be the same step. Now I'm just looking at the cosecant of that angle, which is the reciprocal of sine. Sine is 1 over root 2, so again, this would be root 2. And it is positive because it's in the first quadrant. Everything is positive in the first quadrant. Last one, cotangent. The reciprocal of tangent. Tangent of pi force is just 1, so the cotangent is 1. Oops, that's fun. All because it's the same reference angle. No matter if it's, sorry guys, same reference angle, but I'm talking about the angle, negative 7 pi over 4. Okay, continuing on. Here it is in radian, and here it is in degree. I'm going to set them up for you, and then I'm going to have you finish some for extra points. Looking at the beginning, it's the same angle, so let's draw it out. It's important when you draw out to really understand how many times you're going around. Here's 0. Here would be 6 pi over 6. And here would be 12 pi over 6 as you do that rotation. Pi, 2 pi is a full circle. So I'm doing 11 pi. Here's 6, almost getting to 12, and I'm going to stop there. Leaving my reference angle, pi over 6. So for all of these, the reference angle is pi over 6. Reference angle pi over 6. Sine of pi over 6 is really the sine of 30 degrees, 1/2. Quadrant 4 would mean sine is negative. So your sine of this angle in radian is positive 1/2. You go ahead, find the cosine, and find the tangent. Using the same reference angle, same 4-step process. Back to degrees, what we love. Part A, degree, 405. Okay, let's graph that. That's going to be a full rotation, so 360 degrees plus a little bit more. Like right there. Reference angle is right here from the x-axis to the terminal side, and that's 45 degrees. Reference angle, 45 degrees. Cosine of 45 degrees is root 2 over 2. We're in quadrant 1, so all positive. So the cosine of this angle is positive root 2 over 2. I'm going to have you do part B. Part C, it's the same drawing here. So I'm going to show part C. I'm just going to pretty much copy this down, because that is the measure for 405 degrees. Reference angle is 45. I'm finding now the sine of that, which is the same root 2 over 2. Quadrant 1, so all are positive. So the sine 45 405 is root 2 over 2. Hopefully this brings back good memories. I'm going to also leave this one as an exercise. So please, if you want some extra credit, you want an extra practice, and you want to feel super confident with the 4-step process in degree and in radian, you'll complete those 4 highlighted problems. You also can go through and complete any of these and check the answers that they match, and I'd be happy to talk about it in class. Good luck!